Good evening all. Today we will be seeing about CPU scheduling algorithms in operating system. So what is this CPU scheduling algorithm is? Whenever there is n number of processes waiting for to get its process to be completed, it will be in a queue, and the CPU scheduling algorithms helps us to find out which process to get into its work to be completed. So these are the types of algorithms which we call it as a CPU scheduling algorithm. The first come first served scheduling. In short, we call it as FCFS scheduling algorithm. Second one is the shortest job first scheduling algorithm. The third one is the priority schedule, and fourth one is the round robin scheduling. We will be seeing one by one. The first is the first come first served scheduling algorithm. So from the name itself, we come to know that there is a list of process. The process which comes first will be served first. So let me take an example. We have a list of process like P1, P2 and P3, and its respective burst time is given as 24, 3 and 3. So here there comes a question, what is this burst time? Burst time is nothing but the time which the process needs to complete its execution. That time we call it as a burst time. Let me say for P1, in order to complete its work, it needs 24 milliseconds to complete its work. So let me assume that this process arrive in order P1, P2, P3. So as per the first come first served scheduling algorithm, the first process P1 will be served first. So in order to depict this complete working of this algorithm, we have a scheduling. We have a chart called as Gantt chart. This Gantt chart is drawn like this. So first the P1 comes into a picture because it is the first process which asked for a service. So the first time is 24, so it is from 0 to 24. The next is P2. It needs 3 milliseconds, so 24 plus 3 is 27. Again P3 needs 3, so 27 plus 3 is 30. So likewise we will draw a chart. The performance of this algorithm will be calculated based on finding out the waiting time for each process and finally with the average waiting time. When we consider for P1 there is no waiting time, immediately it will enter for its work, and then P2 24 and P3 is 27. When we sum it up and divide by the number of processes, in this case the process count is 3, we will be getting 17. So what happens if we change the sequence of the process? Let me take this as an example. Let the process arrive in this order like P2, P3 and P1. So P2 needs 3 milliseconds. So it starts from 0 to 3. And then P3 needs 3 again. So 3 plus 3, 6. And finally P1 24 milliseconds. So 6 plus 24, 30. When we calculate same like as by the previous example, we can see here the average waiting time is only 3. We can compare this with that. Here we have a tremendous change where here we faced a 17 and here we got a 3. So this is much more better than the previous case. So what is the problem in this kind of first come first served scheduling algorithm is, it is having an effect called as conveyor effect, which is nothing but when all other processes are waiting for one big process to get out of the CPU, so it has to wait for a long time until the big process completes its work. So which causes a lower CPU and the device utilization. And when we say in specific, we call this FCFS algorithm as a non-preemptive nature, which is nothing but once the CPU has been alerted to a process, the process keeps on the CPU until it releases the CPU. When it will release, once it's completed work, then only it will release the CPU. And it is this manner will provide us a troublesome for time sharing system where each user needs to get a share of CPU at a regular intervals. So in such a case, we have to move to the next type of algorithm which helps us for a time sharing system and will remove the flaws in a first come first served scheduling. The second type of scheduling algorithm is the shortest job first scheduling algorithm. So this algorithm associates each process with the length of its next CPU burst, which is nothing but we schedule the process with the shortest time. So this is better than FCFS, where the problems of this conveyor effect is overcome to this kind of scheduling. So whenever the process which is having a shortest time can be processed first based on the scheduling algorithm. So what happened in such kind of scheduling is, what is the benefit is, so that the big process will be processed at the end, and the small shortest time process will be processed very easily and fast. So in such a case, it provides an optimal solution for drawbacks in the previous case of scheduling algorithm. But one difficulty is knowing the length of the next CPU request is difficult, and respectively we have to take a solution for it. So this is the example of a shortest job first scheduling algorithm. So we have a list of process P1, P2, P3 and P4, and its respective burst times are 6, 8, 7 and 3. So let me draw a Gantt chart. So according to this shortest job first algorithm, we have to find the process which is having the very short burst time. So in such a manner, we can compare here the first burst time, which is the very shortest, is for the process P4. So P4 will be processed first. So it starts from 0 to 3 milliseconds. So when you compare the next level of burst time, the next least value is 6, which is for process P1. So P1 will be processed second. So it needs 6 milliseconds. So 6 plus 3 is 9. The third process which will be getting into processes P3, where its burst time is the next shortest time, which is 7. So 9 plus 7 is, P3 will enter into it. So 9 plus 7 is 16. And finally 8, which is the final process P to get into a process. So the average waiting time for this particular thing is, when we sum up all together and divide by the number of processes, in such a case it is 4, it gives 7. So this is the example for shortest job first. So this kind of algorithm may be either preemptive or non-preemptive. If it is a preemptive, it will preempt the currently running process. And if it is a non-preemptive SJF, it will allow the running process to finish the CPU burst. And this kind of preemptive SJF scheduling is otherwise called as shortest remaining time first scheduling. The next type of algorithm is the priority scheduling algorithm. Here for each process, a priority number, which is an integer, is associated with each process, and this number is an integer where it starts from 0 or 1, or it will proceed as a integer numbers. And there is no common meaning that the 0 is the highest or the bigger number is the highest or the lowest priority. For all such cases, it depends on the system. That is, it completely depends on the system. So let me see a sample for this priority scheduling. You can see there is a list of process P1, P2, P3, P4 and P5, and its respective burst time are also given. And you can see one more parameter we added, which is a priority. The first priority is given as a number P1 is to process P2. The second priority for process P5. Third priority for P1, fourth for P3 and fifth priority for P4. So the arrival of process will be based on this priority number. In this case, we have taken 1 as the highest priority. It may vary for system. Okay. Then let me see how the Gantt chart can be drawn. The process which is having high priority, that is 1, is P2. So P2 will come first. It is having a burst time of 1. Then the second priority for P5, so 1 plus 5 is 6. Then the third priority is for P1, so P1 10. So for burst time for P1 10, so 6 plus 10 is 16. Then the fourth P3 will come, so P3 2, 16 plus 2 is 18. And finally P4, which needs 1 millisecond, it completes its process. So when we see how we can fix this priority is, it can be internally matched or it can be externally fixed. So the average waiting time for this particular is also calculated in the same manner. That is, average waiting time is nothing but the waiting time for each process, sum of this and divide by the number of processes. And in this case, it is giving me 8.2 milliseconds. So let me see what is this nature of this priority scheduling is. It can be either preemptive or it can be non-preemptive. And a major problem we are seeing here is the indefinite blocking, which we call it as a starvation. What it means is the process which are having the high priority will be getting a chance first, and if it is a big process, it holds a complete work. Until it completes its work, it will not give the chance to the next process. So what the remaining low priority process are is they are lacking to get the thing, and they are in a starvation, and indefinitely there is a blocking. So such kind of thing can be overcome by the technology called as aging. So what is this aging is, by finding out the process which is waiting in a system for a long time, and we can change the priority of such system, and by giving a chance to it by increasing the priority of that particular process. The next algorithm is the round robin scheduling algorithm. This algorithm is designed specifically for a time sharing system. The nature of this algorithm is similar to FCFS algorithm. Along with, we added a preemption to the particular thing to switch between the process. We know well that FCFS is a non-preemptive, but this nature of preemption is added, and the algorithm is named as the round robin scheduling. So what is this preemption added is, it is a small unit which we call it as a time quantum, otherwise it is called as the time slice. So each process will be working based on this time quantum. So the time allotted for each process will be same, so that no more starvation or any problem will occur, all will be processed equally. So once the time quantum is elapsed for a particular process, that is, the process is preempted and then added to the ready queue. So that likewise each and every process will acquire its particular time quantum. It can able to finish, it can work its under particular work will be done by the process. If not, it will be getting its time after the completion of the other process based on its time quantum. And if we see an example for this, so these are the process P1, P2, P3 and its respective burst time 24, 3 and 3. And the time quantum for this sample we have fixed it as 4. It can be anything. We can fix any number. So in such a case, the time quantum is 4. So as per the logic FCFS algorithm, the first process that is going to process is P1. So P1 needs 24 milliseconds to complete its work, but the time quantum fixed is only 4. So what this P1 will do is, it will get its chance, but it can use the processor until only for 4 quantum, that is 4 milliseconds. After that, it will be giving chance to the next process which is in a queue as per the FCFS logic. So the P1, it is 0 to 4. And for P2, actually P2 requires only 3 milliseconds, but actual time quantum is 4, so no problem, it will utilize its time allotted for it. And as like a P2, P3 case is also similar to it or same. So when we see the next slot will be given to P1, but P1 needs only completed 4 quantum, it needs 24, but this 24 millisecond will not be given continuously, it will be slotted as 4 quantums, that is 4 milliseconds, because we fixed a time quantum and the process will be handled in such a way. So this is what the first come first serve algorithm with the preemption, we call it as a round robin algorithm.